The following diagram represents a large Ferris wheel at an amusement park. Points P, Q and R. P, Q and R represent different positions of the seat on the wheel. The wheel has a radius of 50 meters and rotates clockwise at a rate of 1 revolution every 30 minutes. So it's going to rotate this way around, and it's going to take 30 minutes to get back to where it starts. Find the height above the seat above the ground after 15 minutes. So 1 revolution is every 30 minutes, and therefore after 15 minutes it would have gone halfway to this point here. So this distance is 50 because we're told that. This distance is 50, but we need to remember it is 1 meter off the ground to begin with. So after 15 minutes, P will be at P dash, this point here, halfway round, and hence the height above the ground will be 1 plus 50 plus 50, 1 plus 50 plus 50, which is 101 meters. After 6 minutes, the seat is at point Q, the point here. Find the height above the ground at Q. So we need to find above this distance here, is what we need to find. Okay, we know that 30 minutes, it will go round once, that's 2 pi radians. 1 revolution is 30 minutes, and there's 2 pi radians in a circle. Therefore, 1 minute, we have to divide this by 30, 2 pi over 30, which is pi over 15. And therefore 6 minutes will be 6 times pi over 15, which cancels down to 2 pi over 5. Therefore this angle here is 2 pi by 5. If we draw this one here, we get a right angle triangle, and what we can do, we can calculate this height, this distance here, and then take it away from 51. So consider triangle QON, so it's QON. This is 2 pi by 5, this is a right angle, this is 50. A little bit of right angle trigonometry, adjacent hypotenuse, because we want to find this distance. Cos theta is adjacent over hypotenuse. Therefore cos of 2 pi by 5 is equal to ON over 50. And therefore ON will be 50 cos 2 pi by 5. And then in order to find the height above the ground of Q is the same as this distance here. This distance here is the same as this distance here. We know from here to here it is 51, so it's 51 minus this. And then working this out on my GDC using my calculator in radian mode, which it should be by default, that gives me 35.549, which is equal to 35.5 meters. Right, the height of the seat above the ground after t minutes can be modelled by the function h of t is equal to 50 sine bracket b brackets t minus c brackets plus 51. Find the values of b and c. Because we've got 2 unknowns, we need to use 2 bits of information. First of all, obvious one to take is when t is equal to 0, the height is 1, because it's that distance. So 1 will be 50 sine brackets b brackets 0 minus c close brackets plus 51. If we take 51 from both sides, then we're going to get minus 50 on this side. On this side we just get 50 sine b 0 minus c, and then divide by 50. We're going to get minus 1 is equal to sine of b 0 minus c. Now if we look at the graph of sine, and you should always be able to sketch a graph of sine. This is just a standard graph of sine. It is minus 1 at 3 pi by 2. So that means that 3 pi by 2 must be equal to this angle here. All of this must be 3 pi by 2 in order to make this minus 1. Right, we've still got 2 unknowns, but if we find another height, well, we just worked out when t is 15, another height is 101. So 101 is 50 bracket b 15 minus c close brackets plus 51. Again, taking 51, we're going to get that 50 is equal to 50 sine b 15 minus c. Dividing by 50, we're going to get that 1 is equal to sine b 15 minus c. Where is this equal to 1? Well, it's going to be this angle here. So all of this must be equal to pi by 2. So therefore we have pi by 2 is equal to b brackets 15 minus c. So we've got 2 equations, that's equation 1 and equation 2, and then we're going to solve them simultaneously. Right, the easiest thing to do is to do 1 divided by 2. 3 pi by 2 divided by pi by 2 is 3. It's like saying a half into 3.5, 1.5 is 3 times. The half goes in 3 times. B divided by B, they cancel out, and then you get minus C over 15 minus C. The B's have cancelled out. Right, we now solve that. So we get 3 brackets 15 minus C is equal to minus C. Expanding the bracket, 45 minus 3C is equal to minus C. 45 is equal to 2C, and therefore C is 22.5. We'll substitute that back into one of the two. Let's just substitute it back into 1. Remember, b times 0 is 0, so we're going to get 3 pi by 2 is going to be b, this bit is 0, so we've got b times minus c, so we're going to have minus b times our answer to c, which is 22.5. Now divide by 22.5, if we do that, that becomes 45, 2 times 22.5, and then it's going we have to also remember it's minus when we take the minus over to the other side, so it's minus 3 pi over 45. 3 is going to 3 and 45, so we get the b is minus pi over 15, c is 22.5. Quite a difficult question, this. Right, the last part is going to allow us to use our GDC. Hence, find the value of t for the first time the seat is 96 meters above the ground. So we've got h of t is 50 sine b t minus c plus 51. Putting in our values, h of t is going to be 50 sine minus pi over 15t minus 22.5 plus 51. We require 50 sine minus 15 over pi over 15 brackets t minus 22.5 plus 51 equal to 96. So to do that, we're going to use our GDC. Right. Right, so go into our GDC. So go into the GDC and go into a graphing mode. Right, we can set our window up to begin with. So window zoom, window settings. I do always good to have a little bit of y-axis. So I'm going to put -2, and we know that 1 revolution is 30 minutes. So we'll put 32 just to take it a little bit further. And the y maximum, we know that the height went up to 101, so we'll put the y maximum about 120. And press OK, so we'll get a reasonable set of axes. So we'll put in the first graph, which is 50 times sine brackets, the brackets all there, so we want minus pi divided by 15 brackets x minus 22.5, and then go out of the brackets and then add 51. Enter. So we got our nice graph there. Okay, just going to try and pull out the label a little bit out of the way a little bit. Okay, we need to put on 96 there, so command G and then put in 96 and press enter, and we need the first point of intersection, which is there. So to do that, we go menu, analyze the graph, intersection, and go to the left and to the right. Okay, we can also use the graph to check our answer to the first bit by where we had to find what the height was after 6 minutes. So if we go to trace and graph trace and then enter in 6, press enter again, press enter and then escape, then we can see we get the right answer, which is 35.55, which we get for part B. So we've checked our answer for part B there is okay as well. So the answer to the problem is 12.85. On my exam script, you would draw a graph, so rough graph from 0 to 30. Remember, it doesn't actually go to 0, it's 1 at the beginning and 1 here. Okay, draw on the other one at 96, mark on the point of intersection, which is there, and 12.85. and therefore the time is 12.9 minutes to 3 significant figures. This here was just me verifying my answer to part B. Okay, I hope you've understood. Quite a difficult question. I thank you very much for watching.